So if we look at the next section here, we're given more transformations and we want to graph. But again, the key to graphing is still that your graph is centered around the vertex. So if we can identify the vertex, that's going to be a huge help when graphing without a calculator especially. So let's start with that. And let's identify what the vertex is on this problem. V stands for vertex. When we look at the vertex, in general, what you've heard me say is change the sign, keep the sign. Well, when we change the sign, what we're looking at is we're looking at something that is added or subtracted to x in a parentheses. And we don't have a parentheses, therefore we don't have something added or subtracted to x in a parentheses. In other words, we have nothing, which means that we're not going to go right or left, but we do have the -5, and that's the keep the sign. So our vertex is going to be 0, -5, and I'll just graph that real quick over here. 0, -5. But we have to identify what are the transformations of this graph. And in general, when we read a graph, we read it from left to right. So the first transformation is coming from the 2. The 2 outside of the x is going to be a vertical stretch. Ooh, gotta spell it right. Vertical stretch. There we go. By 2. And our other transformation, we were kind of able to identify by finding the vertex, which is we graphed going down 5. So in terms of our transformations here, everything is going to revolve around this orange vertex. But let's deal with our vertical stretch now, which is by 2. That means that this is going to be multiplied by 2. The up, the y value, we're still going to go right 1, but instead of going up 1, we're going to go up 1 times 2. We're still going to go right 2, but instead of going up 4, we are going to go up 4 times 2. And 4 times 2 is 8. Instead of going right 3, up, and not instead of right 3, I'll eventually say it correctly, we're still going to go right 3, but instead of going up 9, we're going to go up 9 times 2, which is 18, and we're only going to graph what fits on the graph here. If it goes a little bit off the graph, fine, but I'm not going to graph points 18. Again, centered around this orange point. Now that we've calculated our values here, we're going to go right 1, up 2. We're going to go right 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. The pattern is the same on the left. We went right 1 up 2, so we're going to go left 1 up 2. We went right 2 up 8, we're going to go left 2 up 8. And do the best you can to draw the picture. But you can mentally check this here. Does this look like a skinnier graph? Because that's what a vertical stretch does to our function. It makes it look skinnier. It elongates that graph. As we look at problem number 2, again, we need to identify the transformations, but maybe it's easiest to start with the vertex. And once again, in terms of the vertex, what's inside the parentheses? We change the sign. So we have a parentheses on this particular problem. It says x plus 2. I'm going to make it negative 2. There's the change the sign. Then we look outside of the parentheses. What's added or subtracted outside of the parentheses? Well, nothing is added or subtracted outside the parentheses. So our vertex is negative 2, 0. So here's our vertex. We're going to graph that right now because everything's going to be centered around that point. And then we're going to come over here and we're going to look at our transformations. We read the graph left to right. And the first thing, for lack of a mathematical word, is the negative. And the negative reflects our graph. And you may want to look at the chart in the end of your packet to find out how that reflects. But it reflects the graph over the x-axis because the negative is outside of the function. The negative is separate from the 1/2, which is our next transformation. And the 1/2 is going to vertically compress by 1/2. We already know what the plus 2 does inside the parentheses, because in order to graph our vertex, what we did is we moved our graph left 2. But just to say it one more time, the negative is separate from the 1/2. That's a big deal. The negative does one transformation, the 1/2 does another. But once we know that, we can apply this to our vertical compression. But you can't see it on the video, but I'm taking my hand and I'm flipping it upside down because we have a reflection over the x-axis. That's why on our box here it says down, but right 1, down 1, the right one's not going to change, but the down one is going to be 1 times 1/2, which is 1/2, 4.5. The right 2, down 4, the down 4 is what's going to change. It's going to be 4 times 1/2, and 1/2 of 4 is 2. The right 3, down 9, the vertical part of this is what's changing. The 9 is going to change. 9 times 1/2 is 4.5, or 4.5. And we can get the right side, which is going to allow us to get the left side. Right 1, down 1/2. Right 2, down 2. Right 3, down 4.5. And then we copy that on the other side. Left 1, down 1/2. Left 2, down 2. Left 3, down 4.5. And do the best that you can to make it a U-shaped curve. I hope your picture's better than mine. We reflected over the x-axis. We vertically compressed the graph, and we moved our graph left 2. You can mentally check that with your list that you made to start the problem with your transformations. As we flip our paper over, we have to write some equations, and that was part of the practice that you might have tried already, that I just think we need a little bit more clarification on. But if we're given the descriptions, we want to write the quadratic in vertex form that's undergone those transformations. The vertex form is y equals a times x minus h squared plus k. So when we come over here to write our equation, I start with kind of a basic setup. I do y equals, leave a little space, put a parentheses squared in there. That gets us going in the right direction. But we have to know where the different transformations go. First things first, a reflection over the x-axis. That's outside the parentheses with a negative. That's a reflection over the x-axis. Next, a vertical stretch by 4. Well, vertical stretch or compression, those are both outside of the function. 4. Then it's a shift of 6 units down, a third outside of the function. Outside of the function means outside of the parentheses. So we just need to get our other variable back in there, which is our x. Negative 4x squared minus 6. Again, the negative is the reflection over the x. The 4 is the vertical stretch, and the minus 6 is down 6. Once again, y equals, leave a little bit of space, parentheses squared, and then we want to fill these in. So the chart at the end of your packet might be helpful when you're practicing these. Vertical compression, we just said it. Stretch or compression is outside of the parentheses. Vertical compression by 1/2. A reflection over the y-axis. That means our negative is going to be inside the parentheses. And then a shift of 3 units up. Up or down is still going to be outside of the parentheses. Chart at the end of your packet may be helpful. Same idea on problems 3 and 4. A shift of 5 units left. Vertical compression by 1/4 and a shift of 8 up. Y equals, a little bit of space, parentheses, squared. 5 units left. Left or right is an inside idea. So it's going to be inside the parentheses. But it's going to be plus 5. Again, if you think about it, what do we always do? We do change the sign, keep the sign. So we always change the sign from the parentheses. That's going to get us to move left. The 8 up would be the plus 8. So again, change the sign, keep the sign. That's going to give us our vertex. We still have a vertical compression. And a vertical compression is going to be outside of the parentheses. Here's our 1/4. And lastly, a shift of 2 units down, a shift of 3 units right, and a vertical stretch by 3. A shift of 2 units down, minus 2. A shift of 3 units right. Right or left goes in the parentheses, so it's going to be x minus 3. Change the sign, keep the sign. And the vertical stretch by 3. The vertical stretch goes outside of the parentheses.